contextual design, right? This contextual design are of three types, right? Number one, we can use external references, which we covered, right? Number two, we can use external parameters. You know how to create parameters. And yesterday we covered a very important topic called publications. So we can use external publications, right? This is the thing which is very important for you to understand, because when you get into any of the OEM, whether it is, say for example, Ashok Leyland defines, or you get into Renault Nizara, R&T, PCI, or you get into any of the aerospace, whether it is Airbus, Boeing, Bombardier, Embraer, Airbus, any of this, they will have certain procedure of design aspects. They may use either of these methods to use it, okay? External reference, external parameters, and external publications. So what is this? We use it. So as we discussed, external reference means I'm going to use an external reference which is contextually linked with other components. So how you design is called external. So you can see a geometrical set telling that this is externally linked with other component, right? Linked with other component. That could be one. So then we see parameters. What could be the parameters? I'm going to give f of x relationship between the components, between the parts within the same product. So I'm going to give relation between the features between different parts in context to product, okay? So this is very much important. Then external publication, yesterday we discussed. What we do, we publish the edges, lines, right? All the stuff. So we are going to use external publication. So external references, like it could be edge, or it could be face, or it could be plane, whatever it could be. We can use it for geometrical design. So these are the three methods of contextual design. So they will ask you in interview, what are the different types of contextual design? So you can tell, we can design an assembly using external reference, external parameters, and external publications. So all the concept, all this is that if I have a shaft, see this is my shaft, right? This is my shaft, right? And have a flange. My shaft diameter and flange diameter, I'm going to equate it. That's the concept. So if I do any changes on my flange diameter, your shaft diameters should change. And similarly, if I do any changes on the shaft, the inputs has to change accordingly. So that means this is the design concept which we use typically for any of the assembly process. Is it clear? This is what this method, whatever I'm just telling you, is it clear? So yeah. Yes? Okay. Let me get into the other one. Okay, I'll just, okay. Now what we'll do is that we will try to create the same aspects, whatever we have seen in the design aspects, like external references, external parameters, and external publications. These are the three methods, right? I'll just brief you out now. Go to File, New. I just told you already, but I'm just going to give you a clear insight. Product, and I'm going to insert assembly design. In assembly design, I'm going to use a new part. I'm going to use a new product. Insert a new part in this one. So this I'm going to design using this shaft. So I'll get back to my part modeling, where I'll just get into mechanical part design, right? Currently I'm in mechanical part design. So I'm going to use the sketch, see this sketch, and going to give a relationship. See this, I'm going to give a formula between these components. You know this, right? So this I'll give the dimension, and this also will give the dimension. So this is my radius, and this is my radius. Okay, something like that. So exit this, and I'm going to pad this flange first for a dimension of 10 mm, right? Give OK, you get this one. So now this dimension are given as 10 mm, this one. So let me use one more part. I'm going to insert a new part in this. No, I'll tell you what is the concept of that one. Yes, I'm going to attack this one, that is double click on my part and click on my sketch, right? I'm going to click on my sketch, and I'm going to use, see this, I'm going to use this plane, which is YZ plane, and here I'm going to use, see this, I'm going to select this edge, right? When I'm going to select this edge, you need to understand that the tools and keep links with the selected object should be checked in, right? In this case, infrastructure, right? Part infrastructure, you can see display, right? Keep link with the selected object should be checked in. You know this one, right? Just give OK. Your process is checked in. So now, instead of drawing the sketch in this, I'm going to use this sketch for my project. I'm going to project 3D elements. So once I click on this one, you can see that a blue gear with a green gear with a chain drive appears. That means this component is contextually linked using external reference, which we discussed already, right? So that means, see that this, I'm going to use this one, give OK, and I'm going to use this one for 150 mm. Okay, so you can see that this is done. So get into this part body, and I'll just click on my graphic card and change this one to my yellow component. So this is my contextual link, right? Similarly, I will just ensure that this feature also I just give some color code so that it is very clear. Now, these are the two things which we have done. Now, if I do any changes, right? If I do any changes in my sketch, typically, say for example, I'm going to change this to 35 and exit the workbench. You can see that your shaft also get changed accordingly, right? So that is what we call as contextual design, right? So I'm just making this contextual design. Now, when you're using this contextual design, right? When you're using this contextual design, understand that this is my edge, which is referred as an external surface for creating external edge for creating the shaft sketch. So this, see the parent-child relationship. Go to this part body, okay, and click on my part body and click on my parent-child relationship, and see this. This is my sketch, right? Show the parent. See that it is showing that the parent is curved. That means this curve parent, you see the parent, it is nothing but it is dependent on part 1. Part 1 which one? Part 1 context. So that's what it is telling, that the edge document is related to part 1.cat part in context with part 1. So that's the meaning which you need to understand. All right. So that means this component is externally linked. And when you do any changes on this feature, say for example, I'm just going to change it to 45. I'm going to change it to 45 now and give OK and exit the workbench. Now you can see that this external reference, right? It is getting connected there. It is connected to that it is broken. It is asking for update. So once you update this one, you can see this curve converting into a fully green dot, right? I'll just go and update it. So update this one. That's it. You get it. So that means when you see that contextually referred, right? When we tell that this component is contextually referred using external reference, you can see a blue gear with a green gear with a chain drive indicating that this is contextually linked. And most of the people, what they do a similar mistakes. Like once it is done, you try to give constraints. Already this is constrained. There is not required for any constraints, right? So why to give those constraints? So I'll go to tools and option. Yesterday we checked it, right? Assembly constraints, mechanical assembly constraints. So I'll just make use any geometry. Yeah, we did it. So now if you use this constraint and this constraint between this pink and this yellow, if you give it, this loop design between the geometry and constraints appear. This indicates that there is no requirement for this assembly to be constrained. That's one important point we can do it. Okay. But can we make this face and this face constrained? So let me see. Contact constraint between this face and this face. That is also not possible because we are defined on a YZ plane, right? YZ plane to define this one. So this is your first step of creating an external reference using the other edges. Okay, we are not used other two varieties. Okay. I will teach you the next method of creating using external parameters. What is external parameters? So if at all, once you have done it, you would like to unlink the external reference. You like to unlink the external reference. What you have to do? Go to this curve, right? Go to this one. See this. Go to this part model. Right? This is my part. Activate the part. Right? Go to this external references. Select this one and make it isolate. You can see that isolate. Once you isolate it, that external reference is isolated. It is broken. So if you do see, once it is isolated, you can see that the green gear with the chain drive has come back to a same part model capabilities, right? This indicates that this component is contextually linked, but it is isolated from the reference geometry. So that is the reason we need to understand that when you use this parameters as references, ensure that once it is isolated, you can't make it back. So it is isolated means totally isolated. You can't make it join once again. The application doesn't have so artificial intelligence or something to fetch that earlier I was connected to that. So now if you see this curve parent-child relationship, this curve parent-child relationship is nothing. So you can see that there is no parent for this. So the parent, there is no parent because it is isolated, right? That's a very fundamental thing which you need to understand. Now, in this case, what I do, I'll just delete this part. Fine. Now I will delete this one also. Yes. Now I'll teach you the next method of giving parameters as a reference. What is that? It is not a parameter. I'm giving external parameter. You need to understand that specific word, what I call as external parameters. Now, in this case, what you do typically is this, that I'm going to give some relationship. When I want to give some relationship, ensure that this external parameter plays an important role. For me, the first and foremost requirement is that tools and options, your parameters should be checked in. You know that tools, option, infrastructure, right? And part infrastructure, your display, your parameters and relationship should be on. Perfect. That's the first step. Now, this is my sketch, right? So what I'll do, I'll just go and create my formulas. You know how to create my formulas, right? I'm just going to create formulas. I'm going to create my new parameters called IR or inner radius. I'm just giving it just to 25. Okay. So that, sorry, not here. The other one, I'm going to give activate this part. So that means the blue one tells that I'm active in this part. Okay, this part. See that? This is my active part. So this part, when I click on this, I'm active in this part. So now I'm going to insert f of x, right? I'm going to insert f of x and create a new parameter, right? Call this one as inner radius. Inner radius. Okay. And I'm going to give a length of 25 mm. Apply it. And just give OK. This is my inner radius. Okay. So next, you can see that my inner radius is appearing. Similarly, I'm going to create my f of x and I'm going to create a new parameter called inner outer radius. And I'm going to give this as 35. Apply it, give OK. And similarly, you know how to give these parameters. I'm going to give new parameter and I'm going to give thickness as 10 mm, something like that. Okay, apply it, you give it. Now see this, what I'm going to do, I'm going to reformula and I'm going to use this one. So this is my inner radius, right? Add formula, I'll make it as is equal to inner radius 25. That is done. And this one, 86, I'll make it equivalent to 35. Just give OK. And my thickness, so it could be the thickness which I would like to convert next. So this is my thickness, right? See that? This is my thickness. So I will make this one add formula which is equal to this one. So just give OK and apply it. Your formula, everything is getting changed. You see this now, right? Now, this is your parameters, right? This is my parameters. So if I do any changes over here, say for example, I change it to 30 or 20, it gets changed, right? You can do that changes, okay? So now, what I'm going to do now is that I'm going to go to the part body of the second part, that is part 2, okay? And I'm going to select my sketch. See that? I'm going to select my sketch. And I'm going to draw my sketch. I'm not going to use any sketch. See that? I'm going to draw my sketch. And I'm going to dimension this one, right? See this dimension, what I'll do is that, observe carefully, this dimension, I'm going to double click on that and I'm going to edit formula. You know how to use this formula, edit. Now I'm going to select that this radius which is active in part 2 and this is active in part 2 is equivalent to my inner radius of part 1. See that? So just click on this one. Keep link with the selected object option is active. Do you want to link it? Yes, I would like to link it. So then give OK. Automatically you can see that this radius becomes 20 mm. That means your external parameters are created. See that? Now you can see that this is external parameter, right? Exit this one. You can see that the external parameter. And how you differentiate that one? You can't see blue gear with the chain drive. It's not there in external parameters. You can see only this external parameters which you can see. There is a difference, right? Parameters and external parameters. And you can see a dot. This dot indicates that you see the parent inner radius of part 1. At any point of time, this is linked to that one. See the parent. So there is no parent for that, right? That means you can able to see that this is driven. You can't change it over here. See that you can't change it. It is blocked. So if at all you would like to change, right? Go to this part and change it to 18 mm. Just give OK. And now you can just do it. So this is my parameter, right? So this is my sketch, right? Also got changed. Now activate this part. Anyhow, it is active. And I'm going to use, this sketch, right? So this is my sketch, right? So this sketch I'm going to use for pad. So I'm going to use mirror and give it this one. So now I have done my external parameterization between this parameter and this parameter. So if at all you would like to do any changes, right? You would like to do any changes. So no need to worry in this case. So just go here, click on this parameter, change this one parameter. So this is the only parameter which you can change to 25. Just give OK. Automatically your product also gets changed. And if you update that, see your shaft also gets changed. Okay. So in this case, once again, you give assembly constraint. There is no meaning of giving assembly constraint. See here it takes. Very important. Understood? Here it takes. Why? Sketch and sketch is only connected. There is no other dimension. So what I can do, I can use snap, move on this component anywhere. That means the sketch and sketch only is constrained, but not the assembly constraints. You need to be very careful on that, right? When external parameters are used, only the formulas are related, only the geometries are getting changed. So that means if you do these changes, say for example, I'm going to do this change to 20 mm. It gets changed, but it will not get aligned. So that means in this case, what you need to understand, in external parameter, whatever you are going to do, it is independent with the axis, right? You have to use assembly constraints and give assembly constraints. So that means it indicates that you can able to create this formula assembly constraints. Any doubt so far in this case? So when you update any of the features over here, say for example, I'm going to change it over here to 20. And once you come back, you can see that this into mark will show that it is going asking for update. Just update it, it gets updated. So remember that assembly constraints plays an important role. So this formula is, see, you can see this formula is external parameters. It creates it. So this is the second method of understanding the contextual design, right? Now I'll go to the third method. So I'm going to delete these parameters. And I'm going to delete this parameter. I'm going to delete this one. And I'm going to delete this pad. So I'm going to update this one. Right? This one. So in this case, what I will do is that now you just see the next method. The third method is called using external publications. So yesterday we learned how to create external publications, and we can use those edges and faces for external publications. So what I'm going to do, see this. This is my edge, right? I will use publications. See, this is my publications part model. As I told you, publications are available both in part level and product level. So in this case, I'm going to use it in product level. So where I'll go to publication, and I'm going to publish which one? I'm going to publish this edge, and you can see that edge is appearing on the screen. This edge. You can make part 2 sketch edge or whatever it could be. You can rename it as you want it. So you can rename, right? The sketch edge, for example. Sketch edge for part 2. I'm just checking for part 2. I'm just giving that one. Just give OK. I publish that. This is my sketch edge for my part 2. And even this face I would like to publish. See that? Tools, part model. Yeah, tools, and I'm going to publish this face also. Right? Sketch plane. I'm going to write this one as sketch plane or sketch face. Sketch face. And just give OK. You get that one. So now what I did, I used this tool, I published it, and I will go back to my part 2. So yes, I'm going to go back to my part 2. So I'm going to delete this sketch. And now see that which is active, my part 2 is active. I'm going to do a sketch on this face. Which face? Sketch face, which I published in my part design. Just give OK. So it gets published. You can see that yellow face, right? This is my published. Exit this, and I'm going to use a sketch, or I'm going to use this edge, and I'm going to use project for my reference. So that means these are externally linked. See that? I'm going to exit, and I'm going to pad this one and give OK. So now, if you see that external reference is happening using publications, you can see P. So they will ask you in an interview, external reference, where if I see P, means what does that means? It means that this component is externally published and externally linked to the other part. You need to understand. See that same what you saw in external references, you can able to see the same thing over here also, external publications also. So whatever you do changes here, get changes there also. Say for example, you go there and change your sketch to, so for example, this is a relationship. I'll just delete all this relationship. Before this was old, I'm just deleting it. Exit this, just delete this one. I'm just deleting this. So if I update, so that gets changed, and if at all, go and do any changes on the sketch. So this is my 20. I'm going to make it to 25. So this sketch is not published, right? And go to this assembly, and that's the reason we tell don't give red color, right? Always give the color which is intended. So I'll just go to my product and update it. So now you see that external reference is getting published. So this is my external publish. Okay, I'm going to hide this one. See? So is it clear that these are the three methods of creating the, what you call, the parameters or the contextual designs? So what is the takeaway? When you use the parameters, external parameters, you can't see this blue gears and gray greens, number one. And number two, you can give assembly constraints between this sketches and edges, because here, can we try this one and this one, the same loop design will come, right? Like what we use external references. There is no difference between published and external reference. Only thing is I'm publishing in part level. You know how to use publications. Yesterday we discussed how to use this publication for assembly purpose. So that level it is being used. Okay. So what is the meaning? You can use either of this method for your design aspects. Okay. Better when it is for a very specified dimensions or geometry, I would recommend use parameters, where number of instance, or you are going to use rectangular patterns or user defined patterns, something like that. I would recommend always use what you call the parameters relationship, all parameters. When it's most of aesthetics or more of reference element plays an important point in terms of edges, phasers or sketches, better always publish those geometry and use it. If at all you're not publishing, you can directly use as an external references. But I will recommend that if you publish and do it, you have some indication that this edge is so important for my design, right? See that this sketch edge for part 2, sketch face part 2, if you define it, it makes a sense, right? For that, the third person who is going to design this, he will understand, hey, my publication is going to use this one, and I'm going to use this as a factor for the design aspects, right? So you're going to set a very clear identification and indication that this is my externally linked components. Okay. Hope you understand about these 3 important parameters of how to use contextual design with reference to external references, external parameters, and external publications.